I thought today we'd kind of take a slightly different slant and talk about something in the melt shop, specifically when chemistry might be off on a heat and we need to figure out what we can do to remediate or even turn this into a different product potentially that we can fulfill with the chemistry we have. As we're seeing in the mills, you've got folks with a lot of experience that have seen production for the last 10, 20 years in that mill, and they're able to make on the fly accurate calls about what they should be doing. But as we know, mills are running leaner than ever. We have retiring workforce and less experienced folks coming into these roles and making these decisions. And I think that's one of the areas potentially that AI can help, is help support them making the right decision at that moment in time. I want to see if there are any examples from our customers where we're seeing this type of thing and where we're seeing our technology be applied to solve for this kind of experience gap problem. Karol, I don't know if you want to kick us off with some examples that might spring to mind from your customers.
What I've learned and what I realized from talking to many mills, that there is pretty often one common scenario. There is this one particular guy at the mill, and he's kind of the guru of chemistry and knows regrading possibilities by heart. This guy needs to just have a look at the chemistry samples, and from the top of his head, he knows which kind of direction it can go, which are the possible regrading, reclassification scenarios. Of course, it's to avoid off-spec production, it's avoid scrapping. Definitely great to have someone like this in the mill because it's a very valuable resource. But on the other hand, when I was asking what's your alternative, then the answer was pretty often, yes, we are aware of it. We are aware that this guy is going to retire most probably soon, and it's not a sustainable solution, but we don't have another solution there. With AI and regrading purposes, I've experienced with customers that they are able to spread this very important knowledge about regrading possibilities across the team. They're not only relying on one particular guy. It's not that super fragile solution. So we've even experienced from a customer that they reduced downgrading by the usage of AI by more than 40%.
And Patrick, this notion of AI and helping support decision making to avoid downgrades and things like that, are you seeing similar things in your customers in the Americas?
Yeah, I mean, I think I could put two kind of examples to add to what Karol was saying there. On the being able to use AI to diagnose problems, right? I see even newer engineers or mills are making new grades. Some of these younger engineers might not have some of the experience previously to say, okay, how do I troubleshoot this? They're using Fero's software to troubleshoot issues with new grade development. So as they're playing around with those chemistries and trying to put stuff into spec, they're able to quickly see kind of the impact of the changes that they've been making. So that's one area. And then on kind of the 40-year tenured melt shop metallurgist, right, being able to pass that knowledge on. When we made our diagnostics tool about 2 years ago, one of the things that shortly got pointed out to me probably 5 to 6 months later is that being able to do a lot of these studies, like kind of digital twin studies in Fero, is allowing our customers to onboard new engineers and help them understand the decisions that have been made historically and allow them to make better decisions going into the future. We're even seeing some of our customers using this as a training tool. So what they're doing is taking Fero's software and they're looking back historically, and then they will say to a new engineer, hey, go look at the first week of April and look at the events that occurred in Fero, and then look at the decisions that we made, because you can see this all in the data. Are there other decisions that could have been made that, you know, might have saved a heat or might have improved our quality or saved us some money? Why do you think the person made this decision? And then they can go back and work together with the tenured metallurgist to say, oh, how did you come up with this decision? This is what the data is showing. I get this, and I can now see when I see this event in the future, I can go and make this similar decision. So it's really giving new engineers a way of accelerating themselves into the field.
So I think there's a couple of things I just want to call out from what you've both shared. Number one, capturing the experience of that tenured metallurgist, and whereas they can just intuitively, based on their experience, make the right decision to prevent a downgrade and do a chemistry adjustment, being able to capture that in an AI platform and share that information so that less tenured professionals can make the same high quality decision. That seems like that's one area. Patrick, what you've also shared is that it's a really good training tool to help ramp up these less tenured, less experienced so that they can see historical data, historical performance, and use that as a way to get up to speed on all the variability they might see in the mill. Karol, I don't know if you have maybe another example where the AI is also providing kind of decision support as to changes that could be made in order to save a heat from your customers?
I have a pretty good example with the digital twin. My customers, I've experienced that they use digital twin of their processes, for example, for seeing and testing out their thoughts and hypotheses. It's more like a safe space or sandbox environment where they are not affecting or they are not making changes to the real production. They are just making changes and simulating it how it's in the sandbox environment. And that's pretty cool because they can test out, hey, what's happening if I'm adjusting ferroalloys in the ladle furnace stage, or what's happening if I'm increasing the annealing temperature to the predicted final mechanical properties at the end of the line.
Yeah, I think the whole value of a digital twin, I have one example from a Midwestern customer that actually, Patrick, you work with. As you said, Patrick, earlier, they use the digital twin to support recipe improvement or recipe development for new grades. That historically might be a process that would have taken them weeks, and now they're able to do in hours and days through the support provided by a digital twin powered by AI. The other takeaway, though, or the other question would be around trust. Our audiences in these mills are engineers, rightly so. They're skeptical and really want to understand why and how these AI technologies are making these decisions. And I think it's really important. And one of the things that we focus on a lot when we work with our customers or we're piloting our technology is conveying the reason why the AI is making the suggestions. And I think giving them that context is really important so that they actually trust the information that they're provided. All of the use cases that you've just shared is predicated by the fact that they need to understand and trust those recommendations so that they act on it. And then ultimately the business gets the value from their actions based on the recommendations from the AI. And just to circle everything back to where we started this conversation about those tenured professionals in the mill, one of the questions we get asked a lot is, where should we start? I think if there are only a couple of people in your production that can make the right decision in a specific domain, that might be a good area to pick about, hey, where can we go capture that knowledge and leverage AI to help others, perhaps without the experience, make the same decisions. So that's always a good place to start.